The Tuesday morning began like any other at the underground facilities in Natanz, in the heart of Iran. The desert temperature already exceeded 40 degrees by 10 in the morning, but inside the nuclear complex, thousands of IR-1 centrifuges spun in absolute silence, separating uranium at speeds that defied human comprehension. Each machine operated at more than 1,000 rotations per second, a microscopic ballet that transformed ordinary nuclear material into fuel capable of powering reactors or, with additional processing, manufacturing weapons of mass destruction. What the Iranian operators did not know was that at that exact moment, technicians from a German company specializing in industrial cooling systems were walking through the corridors of the complex, carrying diagnostic equipment and laptops connected to the facility's internal network. They wore standardized blue uniforms, carried apparently legitimate credentials, and spoke German with a native accent. According to official documentation, they were specialists sent to perform preventive maintenance on the air conditioning systems that kept the centrifuges at an ideal operating temperature. The reality was significantly different. The three men walking through the corridors of Natanz were not German, although they spoke the language perfectly. They did not work for any cooling company, although they knew every component of the systems they claimed to repair. And the devices they discreetly connected to the Iranian operators' workstations were not air conditioning diagnostic equipment. They were delivery vectors for what would become known as Stuxnet, the first cyber virus specifically designed to cause physical destruction to industrial infrastructure. A digital weapon developed in collaboration between Israeli and American intelligence, it was capable of turning nuclear centrifuges into instruments of self-destruction. The operation unfolding at that moment represented years of planning, involving cyber warfare specialists, nuclear engineers, field operators trained to pass as civilians, and a network of front companies created specifically to provide credible cover for the infiltration, because inserting a virus into an Iranian nuclear facility was not simply a matter of hacking computers remotely. It required physical access to internal networks, which were isolated from the internet exactly to prevent cyber attacks. It required intimate knowledge of the industrial control systems that operated the centrifuges. And it required a delivery method that allowed Israeli operators to walk freely inside one of the most guarded facilities in the world. Air conditioning was the perfect answer. Industrial cooling systems are complex, require specialized maintenance, and are connected to the same networks that control critical equipment. Air conditioning technicians have authorized access to restricted areas, work with sophisticated electronic tools, and no one questions when they connect diagnostic equipment to control systems. It is a profession that combines manual labor with technical knowledge, allowing intelligence operators to blend in with legitimate employees without arousing suspicion. And in a nuclear facility in the middle of the Iranian desert, where air conditioning represents the difference between normal operation and thermal catastrophe, specialized technicians are received as saviors, not as potential threats. Mossad operators had studied this vulnerability for months, identifying German companies that provided maintenance services to the Iranian industry, creating fake documentation that would withstand superficial checks, and training on mock-ups of the Natanz facilities, built in classified installations in the Negev desert. They knew the layout of the corridors, the location of security systems, shift change schedules and maintenance protocols that would give them access to the areas where the centrifuges operated. Most importantly, they understood that the success of the operation depended not only on inserting the virus, but on doing so in a way that the Iranians would never suspect their systems had been compromised. Stuxnet was designed to operate in absolute secrecy, slightly modifying the rotation speed of the centrifuges to cause excessive vibration and gradual mechanical failure, while reporting normal conditions to human operators. It was a digital saboteur that lied about its own actions, creating the illusion of normal functioning, while methodically destroying the equipment it claimed to protect. The fake technicians knew they had only one opportunity. Once the virus was detected, Iranian countermeasures would make future infiltrations impossible. Every movement, every connection, every second spent inside Natanz carried the weight of an operation that had cost millions of dollars and years of preparation. As they walked through the underground corridors, carrying digital destruction in devices that looked like common repair tools, they knew they were executing one of the most ambitious sabotage operations in modern history, one that would redefine the limits of cyber warfare and demonstrate that even the most secure facilities in the world could be penetrated by determined operators with the right cover. The second man on the team, who identified as Klaus Weber in the forged German documents, focused his attention on the main control system that monitored the performance of the centrifuges in the western sector of the facility. His fingers moved with calculated precision over the workstation keyboard, apparently executing cooling system diagnostic routines, but in reality navigating through the industrial control menus that governed the operation of the most sensitive machines in Natanz. Each centrifuge represented months of specialized manufacturing, costing tens of thousands of dollars and operating at tolerances so precise that temperature variations of a few degrees could cause catastrophic failures. The air conditioning system was not just environmental comfort, it was a critical component of Iranian nuclear infrastructure, and any technician working on its maintenance would have legitimate access to the controls Weber was now exploring. He had memorized every menu, every parameter, and every security protocol during months of training in Israeli facilities that exactly replicated the Iranian configurations. He knew the Persian operators used slightly modified versions of the German cymatic software produced by Siemens, and that these modifications created specific vulnerabilities that Stuxnet had been designed to exploit. The virus Weber was preparing to insert into the network was not a conventional program. It was a digital predator of extraordinary complexity, containing more than 500,000 lines of code, written by specialized cyber warfare teams. Stuxnet had been tested against exact replicas of Iranian centrifuges, refined through simulations that reproduced every aspect of the Natanz operation, and programmed with intimate knowledge of the security procedures the Iranians used to protect their systems. It was capable of spreading through isolated networks, using previously unknown vulnerabilities in Windows systems, hiding from antivirus software through digital certificates stolen from legitimate companies, and modifying its own code to avoid detection by automatic monitoring systems. But its most impressive feature was its lethal specificity. Stuxnet did not attack just any industrial system. It attacked only nuclear centrifuges manufactured by the Iranian company, with specific configurations operating at specific speeds, with specific control protocols. It was a digital weapon designed to hit a single target in the entire world, the Iranian nuclear program. Weber inserted an apparently common USB device into the workstation, and the code began its silent infiltration. First, the virus mapped the internal network, identifying every connected computer, every active control system, and every communication protocol used between machines. Then, it began to replicate through the digital infrastructure of Natanz, jumping from computer to computer, using vulnerabilities that even the original developers of the systems did not know existed. It was like an electronic ghost walking through digital walls, invisible to Iranian detection systems, but mapping every aspect of the nuclear operation with photographic precision. Meanwhile, Weber continued his performance as an air conditioning technician, checking ambient temperatures, adjusting ventilation settings, and documenting his supposed preventive maintenance on forms that would be filed by Iranian administrators as evidence that critical systems were being properly maintained. The irony was delicious. The Iranians were paying for the maintenance of the systems that allowed the Mossad to sabotage their nuclear infrastructure. The third operator, identified as Heinrich Müller, worked in the eastern sector, where older centrifuges operated under slightly different conditions. His mission was to ensure that Stuxnet spread to all connected networks, including backup systems and secondary monitoring stations that the Iranians used to supervise critical operations. Miller understood that the success of the operation depended not only on infecting the main centrifuges, but on compromising the entire digital ecosystem that controlled them. Backup systems needed to be sabotaged to prevent the Iranians from simply restarting operations with alternative equipment. Monitoring networks needed to be corrupted to hide evidence of sabotage until irreversible damage had occurred. And communication protocols between different sectors of the facility needed to be infected to ensure the virus spread organically through the infrastructure, like a carefully orchestrated digital epidemic. Müller had been trained not only in cyber infiltration techniques, but in Iranian operational psychology. He knew the working hours of the Persian technicians, their security check routines, and their typical reactions to system anomalies. He knew the Iranian operators were highly competent, but worked within rigid protocols that created predictable blind spots in their supervision. While apparently calibrating temperature sensors in ventilation ducts, Müller observed the Iranian technicians performing their daily routines. They were dedicated professionals, many educated in European or American universities, working in one of the most technologically advanced facilities in the Middle East. They were not fanatics or terrorists. They were engineers and technical operators who believed they were contributing to their country's scientific development. Seeing their faces, observing their professional competence, and understanding their humanity created psychological tension that intelligence operators were trained to suppress, but that never completely disappeared. Müller knew that the virus he was inserting into their systems would eventually cost jobs, frustrate careers, and potentially cause accidents that could injure or kill innocent people. It was the moral price that sabotage operations always carried, the need to cause harm to individuals to prevent perceived threats to larger communities. It was a calculation that governments made routinely, but that individual operators had to execute with their own hands, carrying personal responsibility for consequences that would extend far beyond the duration of the mission. The infection was spreading exactly as planned. Stuxnet had identified the target centrifuges and begun its work of gradual destruction, modifying rotation speed so subtly that human operators would not notice changes until mechanical damage became irreversible. The virus was simultaneously recording operational data from the centrifuges and playing that data back in a loop to monitoring systems, creating the illusion of normal functioning while the machines silently destroyed themselves. It was a masterpiece of destructive engineering, demonstrating that cyber warfare had evolved beyond simple communication disruption to precise physical sabotage of critical infrastructure. The three Israeli operators knew they were witnessing the birth of a new era in international conflict, where bits and bytes could cause explosions as devastating as conventional bombs, and where air conditioning technicians could defeat nuclear programs that had cost billions of dollars and decades of development. The most dangerous moment of the operation arrived when an Iranian supervisor approached the station, where the first operator, who went by the name Franz Hoffmann, was connecting diagnostic equipment to the main control system. Mahmoud Rashidi, a senior engineer responsible for external maintenance supervision, had noticed unusual activity on the network monitors and was coming to investigate personally. It was exactly the type of situation that turned successful infiltration operations into diplomatic disasters or human tragedies. Rashidi spoke functional German, had studied engineering at the Technical University of Berlin during the 90s, and possessed enough knowledge about German systems to ask questions that could expose inconsistencies in the Israeli operator's cover. Hoffmann knew the next few minutes would determine whether the operation would continue as planned or if they would need to abort and escape before Iranian security was alerted to a possible foreign infiltration. Rashidi greeted him in German and began an apparently casual conversation about technical specifications of the cooling systems. He asked about recent modifications to the control software, about maintenance schedules established by the German company, and about technical reports that should have been submitted before the visit. They were questions legitimately within the responsibility of a conscientious supervisor, but each represented a potential trap for operators who depended on forged documentation and knowledge acquired through intelligence rather than genuine professional experience. Hoffmann responded with calculated confidence, using precise technical terminology and referencing standard German refrigeration industry procedures. He had memorized not only technical aspects of the systems he claimed to repair, but also German corporate culture, professional relationship protocols, and even regional slang that would give cultural authenticity to his performance. It was the preparation that distinguished professional intelligence operations from amateurism that resulted in capture or death. During the conversation, Hoffman continued working apparently on diagnostic routines, but in reality, he was monitoring the progress of the viral infection through discrete indicators on his laptop screen. Stuxnet had firmly established itself in the Natanz networks and begun the detailed mapping process that would precede its destructive phase. The virus was identifying each individual centrifuge, cataloging its operational specifications, and preparing customized attacks that would maximize damage while minimizing the chance of premature detection. It was like a predator studying a herd, identifying the most vulnerable prey and planning attacks that would eliminate resistance before the victims understood they were being hunted. Rashidi was eventually satisfied with Hoffman's answers and moved away to continue his supervisory rounds, never suspecting he had just spoken with a foreign operator who was sabotaging Iranian nuclear infrastructure right in front of him. With the threat of discovery temporarily averted, the three operators accelerated the conclusion of the operation. Weber finalized the installation of additional virus components that would ensure persistence, even if systems were restarted or antivirus software were updated. Mueller completed the infection of backup networks that would allow Stuxnet to reactivate even if the main installation was cleaned, and Hoffman inserted logging software that would transmit data on the virus's performance through communication channels disguised as normal industrial maintenance traffic. These were the finishing touches that would transform a one-time sabotage into a sustained campaign of destruction. In a matter of hours, they would be out of Iran, flying to European destinations on regular commercial flights, carrying authentic German passports and stories of successful completion of an industrial maintenance contract. The effects of their work would begin to manifest weeks later, when centrifuges in Natanz would start failing in anomalous numbers, creating a technical puzzle that would frustrate Iranian engineers for months. Because Stuxnet did not just destroy equipment, it destroyed confidence in the surviving equipment, forcing the Iranians to question the reliability of their entire nuclear infrastructure and delaying programs that depended on continuous and predictable operation. It was psychological warfare combined with physical sabotage, demonstrating that modern cyber warfare targeted not only technical systems, but also the morale and determination of the human operators responsible for maintaining those systems. And as they walked through the corridors of Natanz for the last time, disguised as German technicians completing routine maintenance, the Israeli operators knew they were leaving behind a digital time bomb that would redefine the balance of power in the Middle East and set a precedent for future conflicts, where battles would be fought not only with soldiers and conventional weapons, but with computer codes and viruses capable of turning enemy infrastructure into an instrument of self-destruction. The departure from Natanz proceeded without incident. The three operators completed the maintenance documentation, collected their equipment, and said cordial goodbyes to the Iranian supervisors who had accompanied them during the work. Their tools were inspected by security, but the devices that had carried Stuxnet were indistinguishable from legitimate diagnostic equipment used by refrigeration technicians worldwide. The Iranians had been conditioned to trust German specialists, who had established a reputation for technical competence and reliability in international markets over decades. It was a trust that Israel had identified and exploited systematically, using the prestige of German engineering as cover for one of the most sophisticated sabotage operations in modern history. The convoy that transported the operators back to Isfahan airport passed through multiple military checkpoints, but the documentation produced by the network of cover companies established by the Mossad stood up to inspections without arousing suspicion. It was a testament to the thoroughness of the operational preparation that had transformed the fantasy of penetrating Iranian nuclear facilities into a reality executed by three men carrying laptops and wearing work uniforms. During the flight to Frankfurt, the first leg of the journey back to Israel, the operators used established communication protocols to signal the successful completion of the mission to controllers in Tel Aviv. The message was brief and cryptic. Air conditioning units functioning within normal parameters. Maintenance completed according to specifications. Equipment performance will be monitored remotely. It was code that confirmed not only that Stuxnet had been successfully deployed, but that the operators were safe and the extraction had proceeded as planned. To outside observers, it was routine business communication between a maintenance company and corporate headquarters. To Israeli intelligence, it was confirmation that months of planning and millions of dollars in preparation had resulted in the successful penetration of the Iranian nuclear program. And for the Iranian engineers working in Natanz that evening, it was still a normal day of operation for one of the most advanced nuclear facilities in the Middle East, with centrifuges spinning in perfect harmony and all systems reporting normal performance parameters. They did not know that in the depths of their computer networks, Stuxnet was establishing permanent residence, mapping every aspect of their operations and preparing to launch a sustained campaign of destruction that would cripple the Iranian nuclear program for years. The virus was designed to remain dormant for weeks, operating only as an observer while collecting detailed intelligence on Iranian nuclear capabilities. Only after a comprehensive reconnaissance phase would the destruction begin, and even then it would proceed with such subtlety that human operators would attribute equipment failures to normal wear and manufacturing defects rather than deliberate sabotage. It was patience that distinguished professional intelligence operations from amateur attacks, and sophistication that demonstrated how modern warfare had evolved to include digital weapons capable of causing physical destruction without traditional military engagement. The first manifestation of Stuxnet's destructive capabilities appeared approximately 6 weeks after the initial infection, when centrifuge failure rates in Natanz began increasing above normal statistical parameters. Iranian engineers initially attributed the anomalies to quality control issues in the manufacturing process, or to normal equipment degradation under continuous high-speed operation. Centrifuges were notoriously delicate machines, operating under such extreme conditions that minor variations in temperature, vibration, or rotational speed could cause catastrophic failure. What made Stuxnet particularly insidious was its ability to simulate exactly these natural failure modes, causing centrifuges to self-destruct in ways that were indistinguishable from legitimate mechanical problems. Engineers would examine destroyed equipment, identify bearing failure or rotor imbalance as the immediate cause of breakdown, and order replacement parts without suspecting that the underlying cause was malicious software systematically destroying Iranian nuclear infrastructure. As weeks passed, the pattern of failures became increasingly obvious to the Iranian nuclear scientists monitoring Natanz operations. Centrifuges were failing at rates significantly higher than statistical models predicted, and failures were concentrated among machines operating in specific configurations that were critical to the uranium enrichment process. Dr. Ali Akbar Salehi, then head of the Iranian nuclear program, ordered a comprehensive investigation into possible causes of the anomalous failure rates. Teams of inspectors examined manufacturing records, operational procedures, environmental conditions, and maintenance protocols, searching for common factors that might explain the sudden increase in equipment breakdown. They discovered inconsistencies in performance data that suggested a systematic problem affecting centrifuge operation, but could not identify a specific cause or develop effective countermeasures. It was precisely the confusion that Stuxnet had been designed to create, an obvious problem without an obvious solution. Investigation teams eventually focused on computer systems controlling centrifuge operation, suspecting a software malfunction might be causing equipment to operate outside safe parameters. It was a logical conclusion, given that centrifuges were controlled by sophisticated digital systems that monitored rotational speed, temperature, vibration, and other critical variables. Iranian computer specialists began examining the source code of control systems, searching for programming errors or corrupted data that might explain the equipment failures. But Stuxnet had been designed by some of the most sophisticated cyber warfare experts in the world, utilizing techniques that were unknown to Iranian security specialists. The virus remained hidden deep within the operating system architecture, concealed by layers of encryption and misdirection that made detection extremely difficult, even for experienced computer security professionals. Iranian teams spent months analyzing their systems without discovering the presence of malicious software that was systematically destroying their nuclear infrastructure. A critical breakthrough came when Iranian intelligence services began suspecting industrial sabotage and requesting assistance from Russian computer security specialists who had more experience with sophisticated cyber attacks. Russian experts brought advanced detection tools and analysis techniques that Iranian teams lacked and began a comprehensive audit of Natanz computer systems. It was during this investigation that the first traces of Stuxnet were discovered, hidden in deep system files that Iranian specialists had not known to examine. The discovery was shocking because it revealed that Iranian nuclear facilities had been completely compromised by foreign intelligence services, and that the ongoing equipment failures were the result of a deliberate attack rather than mechanical problems. It was a revelation that forced the Iranian leadership to confront the reality that their most secure nuclear installations were vulnerable to cyber warfare attacks that they had not anticipated and were not prepared to defend against. Once Stuxnet was identified, Iranian teams could begin the process of cleaning infected systems and implementing countermeasures to prevent future attacks. But the damage had already been substantial. Hundreds of centrifuges had been destroyed, setting back the Iranian nuclear program by approximately 2 years and costing hundreds of millions of dollars in equipment replacement and facility reconstruction. More importantly, the discovery of Stuxnet forced the Iranians to completely redesign security protocols for their nuclear facilities, implementing network isolation and digital security measures that significantly increased operational costs and complexity. It was a strategic victory for Israel and the United States that exceeded the initial expectations of the operations planners, demonstrating that well-designed cyber weapons could achieve strategic objectives that would have required military strikes with a significant risk of escalation into a broader conflict. Iranian retaliation was swift, but ultimately ineffective. Intelligence services attempted to trace the source of the Stuxnet infection and identify the operators responsible for its deployment. But digital forensics revealed only that the virus had been developed by a highly sophisticated organization with access to previously unknown vulnerabilities in industrial control systems. Evidence suggested collaboration between multiple intelligence agencies, likely including American and Israeli services, but proof was insufficient to justify formal accusations or diplomatic protests. Iranian cyber warfare units attempted to develop retaliatory attacks targeting Israeli and American infrastructure, but lacked the technical expertise and resources necessary to create weapons comparable to Stuxnet in sophistication or effectiveness. It was a demonstration of how asymmetric warfare advantages that had favored weaker nations during conventional conflicts did not necessarily apply to the cyber warfare domain, where technological superiority could provide decisive advantages for nations with advanced computer science capabilities. For the Israeli intelligence community, the Stuxnet operation was considered one of the most successful strategic operations in Mossad history. A single infiltration mission had achieved strategic objectives that would have required a sustained military campaign with a significant risk of casualties and regional escalation. The operation had demonstrated the viability of cyber warfare as an alternative to conventional military action, in situations where traditional approaches carried unacceptable political or military risks. And the success of the operation established Israel as a leader in cyber warfare capabilities, creating a deterrent effect that would influence adversary calculations for years to come. Most importantly, the operation had bought Israel additional years to pursue diplomatic solutions to the Iranian nuclear threat, providing time for sanctions and negotiations to potentially resolve the crisis without resort to military action. For the Iranian nuclear program, Stuxnet represented a watershed moment that forced a fundamental reassessment of the security assumptions that had guided their nuclear development strategy. The discovery that foreign intelligence services could penetrate their most secure nuclear facilities and cause physical destruction through cyber attacks forced expensive and time-consuming changes to facility design and operational procedures. Iranian engineers had to balance the requirements of nuclear technology development with the need to protect against sophisticated digital threats that were constantly evolving. It was a challenge that added significant costs to the Iranian nuclear program and created ongoing uncertainty about the security of critical infrastructure. And perhaps the most significant impact was psychological. The knowledge that foreign adversaries possessed capabilities to penetrate Iranian nuclear facilities and cause substantial damage without detection created a permanent state of vulnerability that affected decision-making at the highest levels of the Iranian government. For the international community, Stuxnet established a precedent for cyber warfare that raised troubling questions about the limits of acceptable behavior in the digital domain. The operation demonstrated that cyber weapons could cause physical destruction comparable to conventional military attacks, blurring traditional distinctions between peace and war in cyberspace. The success of the operation encouraged other nations to develop similar capabilities, leading to a cyber arms race that continues to this day, and the sophisticated nature of the operation raised concerns about the potential for accidental escalation if cyber weapons were used against civilian infrastructure or caused unintended casualties. It was a new frontier in international conflict that lacked established rules of engagement or mechanisms for controlling escalation, creating potential for misunderstanding and miscalculation that could lead to broader conflicts. The aftermath of the Stuxnet operation continues to influence cyber warfare strategies and international security considerations more than a decade after its deployment. The operation established a template for using cyber weapons to achieve strategic objectives without traditional military engagement, inspiring similar operations by multiple nations targeting various forms of critical infrastructure. The Iranian experience with Stuxnet influenced the development of more sophisticated defensive measures that are now standard in nuclear facilities worldwide, creating ongoing competition between cyber attack capabilities and defensive technologies. And the precedent established by Israel and the United States in using cyber weapons to prevent nuclear proliferation has been studied and adapted by other nations facing similar strategic challenges, contributing to the normalization of cyber warfare as a tool of statecraft. For the three operators who executed the infiltration of the Natanz facilities, the mission represented a career-defining achievement that validated years of training and preparation. They had successfully penetrated one of the most secure nuclear installations in the world, deployed a sophisticated cyber weapon that achieved strategic objectives beyond initial expectations, and extracted safely without detection or compromise. It was a level of operational success that occurs rarely in the intelligence world, requiring a combination of technical expertise, operational skill, careful planning, and pure luck that rarely aligns perfectly. Their success contributed to a broader Israeli strategy of using targeted operations to degrade adversary capabilities without triggering large-scale military conflicts, demonstrating the value of precise intelligence operations in addressing complex security challenges. The legacy of the Stuxnet operation extends far beyond immediate damage to the Iranian nuclear program. The operation established cyber warfare as a legitimate domain of international conflict, creating new categories of weapons and strategies that did not exist when traditional laws of warfare were developed. The success of the operation influenced military doctrines worldwide, leading to the creation of cyber warfare units in the armed forces of most developed nations. And technical innovations developed for Stuxnet influenced the evolution of both offensive cyber weapons and defensive cybersecurity measures that protect critical infrastructure in civilian societies. It was an operation that changed the fundamental nature of international security competition, creating new vulnerabilities and capabilities that continue to shape global conflicts 15 years after 3 Israeli operators walked out of an Iranian nuclear facility, carrying the memory of one of the most successful sabotage operations in modern history. The conclusion of this narrative reveals the complexities inherent in modern intelligence warfare, where success in achieving tactical objectives must be balanced against broader strategic considerations and ethical implications. The Stuxnet operation succeeded in its immediate goal of degrading Iranian nuclear capabilities, buying time for diplomatic solutions and demonstrating Israeli capabilities to potential adversaries. But the operation also established a precedent for cyber warfare that has contributed to ongoing international instability and arms races that pose significant risks to civilian populations worldwide. Perhaps most significantly, the operation demonstrated that in the age of digital connectivity, even the most secure facilities can be penetrated by determined adversaries with sufficient resources and expertise, fundamentally changing the nature of national security in the 21st century. For historians studying the evolution of warfare, Stuxnet represents a transition point comparable to the introduction of gunpowder or aircraft in previous eras, marking the moment when technological innovation fundamentally altered the balance of power between nations and the nature of conflict itself. The operation proved that digital weapons could achieve strategic objectives previously requiring conventional military force, opening new possibilities for nations seeking to project power without traditional military engagement. And the sophisticated nature of the operation demonstrated the importance of technical expertise and industrial capability in determining the outcomes of modern conflicts, where advantage increasingly belongs to nations capable of developing and deploying cutting-edge technologies, rather than those with the largest conventional military forces. A final assessment of the Stuxnet operation must acknowledge both its tactical success and its broader implications for international stability. While the operation achieved the immediate objective of degrading the Iranian nuclear program, it also contributed to the normalization of cyber warfare tactics that pose ongoing threats to civilian infrastructure worldwide. The success of the operation inspired similar attacks by other nations, creating a precedent for using digital weapons against critical infrastructure that serves civilian populations. It is a double-edged legacy that reflects the broader challenges of modern warfare, where technological capabilities often advance faster than international frameworks for controlling their use, creating the potential for unintended consequences that extend far beyond the immediate objectives of military operations. For future students of intelligence warfare, the Stuxnet operation provides a case study in both the possibilities and limitations of cyber weapons as tools of statecraft. The operation demonstrated that well-planned and sophisticated cyber attacks can achieve strategic objectives that justify substantial investment in resources and planning. But the operation also showed that success depends on a combination of technical capabilities, operational expertise, and circumstances that are difficult to replicate consistently. Most importantly, the operation illustrates how intelligence successes in the tactical domain can create broader strategic challenges that must be managed carefully to prevent unintended consequences that undermine the long-term security interests of all parties involved.